guys, Mrs. Spurlock here. I managed to put together a video lecture for you guys this week, so yay. Maybe things will feel a little bit more cohesive than they have in the previous weeks. Before we jump into lecture, there's just one thing I need to mention, and that is I am changing the way I run my office hours for the remaining couple weeks of the year. I am going to have people let me know ahead of time if they want to attend office hours because my Zoom account has had some security issues. So by having you guys do that, what I can do is I can only invite certain people to the meeting and then I can lock it. So if you haven't let me know ahead of time that you want to go to office hours, you will not be able to attend, unfortunately. And I really wish it wasn't like that. I really wish you could just drop in when you needed to, but we're just all doing our best to get all this stuff done. But this should be a really fun, interesting week because we're going to talk about how messages are transferred between neurons and the effects of drugs. Oh, look at that. Let's fix this right here. Mrs. Spurlock with the PowerPoint errors coming in clutch. Couldn't let you guys down. Okay. All right, so first of all, how messages jump between neurons. Messages get from one neuron to another via what are called neurotransmitters. And these are essentially just chemicals that are either released by your brain or certain glands throughout your body, and they affect your neurons. Now, there is a video that I would like you to watch that gives a nice graphic demonstration of what's occurring. So if you haven't watched it yet, go ahead and watch it right now. There's a link in the lecture description. So go ahead and watch that. Now, there are a lot of different neurotransmitters in the body. And just like a lot of the topics we cover, we don't have time to go over all of them. So we're just going to talk about 5 that play a significant role in the way drugs affect our body. So because neurotransmitters affect our body, drugs also affect our body. That'll make more sense in a little bit. The first one's called adrenaline. You might also hear it called epinephrine. Now, these are just 2 names that refer to different parts of the neurotransmitter itself. Adrenaline means that it comes out of the adrenal gland. Epinephrine means it comes out of a gland on top of the liver, which is the adrenal gland. So they're referring to the same chemical. They just have different names, and you'll hear both of them at different times. Adrenaline is what your body secretes in response to stress, and it decreases blood pressure and decreases blood sugar. Decreasing blood pressure increases the amount of blood getting to muscles. It means you have a greater volume of blood getting to the muscles. And decreasing blood sugar means that all the sugar that's typically in someone's blood can then be taken up by the muscles and used to exert a lot of energy. Adrenaline will increase your breathing rate. When you increase the rate of muscle cell usage, you also need to increase the amount of available oxygen because our muscle cells undergo aerobic respiration, meaning they need oxygen in order to make energy. But you guys knew that already, right? Yeah. Noradrenaline / norepinephrine is secreted by the brain, okay? It's not secreted by the adrenal gland. It's secreted by the brain, and once the danger is gone, norepinephrine or noradrenaline is released in order to kind of undo the effects of the adrenaline. So you're going to see increased blood sugar and increased blood pressure with noradrenaline and decreased breathing rate. It's returning you back to a state of normalcy after a state of high stress. Dopamine is released by your brain when your brain wants you to repeat a behavior. Dopamine plays a huge role in motivation as well as learning and excitement. So if I am eating a sugary cereal for breakfast, my brain is releasing dopamine because it's saying, wow, this food source sure is providing me a lot of energy. I want to make sure that I have feelings in the body that make me want to come back and eat the same sugary food again. Now, because we can go buy cereal off of a shelf now, That's not a super good message for our body to send, but it's why we like sugar so much. It's because in a different time of human history, sugar was not so readily available, right? Imagine in the winter without a grocery store, what kind of fruit are you eating? Not very many fruits blooming in the winter, or ripening in the winter. Serotonin is released primarily by your intestines, but actually also by your brain. And in the central nervous system, it will alter a person's mood. The serotonin secreted in your bowels or in your digestive system is there to help regulate the movement of all the stuff that goes through your digestive system. But in the central nervous system, it is a huge mood altering neurotransmitter. It's often one of the first things used to try and treat depression, depending on who it is and what they have going on metabolically inside of them already. It doesn't work for everyone, but it is one of the first attempts to alleviate the symptoms of depression. Endorphins are made in the central nervous system and by our pituitary gland, and they induce feelings of euphoria while alleviating pain. If you've heard of what's called a runner's high is caused by endorphins, and it's actually because your body is in a lot of pain and it doesn't want to keep running. But sometimes the bear is not tired yet and you need to keep running. So instead, your brain tricks you. And it says, you're not in pain, you're having a great time, keep it up. And endorphins specifically play a role in opiate addiction. So classes of drugs. We categorize drugs into classes based on their effects on the nervous system and on the human body and what they bind to. The kind of neurotransmitter that they're trying to imitate is going to determine the kind of receptors that they bind to. So classes of drugs. The first, I think it's 5, come from your book, but then I just added 1 at the very end, and you guys will understand why when we get there. Narcotics are pain relief drugs, but they have to cause drowsiness to be considered a narcotic. When a pain relief drug such as Tylenol or ibuprofen doesn't cause drowsiness, it's called an analgesic. Narcotics, pain relief drugs, they cause drowsiness, and they are highly addictive. A lot of large narcotic producers are dealing with the effects of these long-term addictions that have been caused by the lack of understanding of narcotics before they started being prescribed. Legal narcotics have to be prescribed by a doctor because they are so addictive, and they include things like morphine. Illegal narcotics are never prescribed by a doctor, and they're going to include things like heroin and a drug called fentanyl. Now, you're definitely not going to see fentanyl mentioned in your textbook. Fentanyl is actually a concentrated drug that causes the same effects as heroin, but became a pretty big problem, I believe, in 2018. So it's a very recent drug to hit the illegal drug scene. I don't know. Cardiovascular drugs are drugs that regulate heart and circulatory problems. They're not very addictive, so you don't have a bunch of illegal examples and things like that. Stimulants are drugs that increase the activity of the nervous system, and these are going to include things like nicotine and caffeine. Nicotine is a stimulant. It increases the rate of things going on in the body, as well as caffeine. And illegal examples include things such as cocaine and methamphetamine. Depressants decrease the activity of the nervous system. So that's a good thing about stimulants and depressants. They're named appropriately. Nobody's trying to trick you with the names of stimulants and depressants. And a legal depressant is alcohol. It decreases the activity of your immune system. Illegal examples, the main example I could find was date rape drugs, which are terrible. That's the sort of layman's term for them. But they are exactly what they sound like. People will use them to take advantage of other people out in public. So if you are a person who is out in public drinking a beverage, always be careful that nobody's putting anything in your beverage. Legal forms of depressants are often abused illegally. And then hallucinogens are the last example in your book. When a person is taking hallucinogens, they're seeing things that don't exist, not just seeing, sensing. So they might hear things that aren't there, they might smell things that aren't there, and that's pretty much it. Legal examples, LSD was recently used in an experiment to observe its effects on depression. And what they found is that it actually significantly reduced the symptoms of several people who are suffering from depression. So keep an ear out for that. You might hear more about that in the near future. And then some Native American tribes will use a plant called peyote in religious rituals. And that also induces hallucinations, and under sovereign law, that's legal for them to do. And illegal examples include PCP and psilocybin, which is more commonly known as magic mushrooms. And then the last class of drugs that's not mentioned in your book that I wanted to make sure we talked about is cannabinoids. Cannabinoids are chemicals that bind to cannabinoid receptors. The active ingredient in the drug marijuana, called THC, is actually produced in trace amounts in your body. So you already have these receptors that bind directly to the thing produced by the drug, instead of being tricked into binding to something it's not supposed to. Now for this, when we come to legal versus illegal, in the state of Arizona, a person can be prescribed medical marijuana. And another legal example, just straight up legal example of this would be CBD. So I don't know why I forgot to put that in the PowerPoint. Oops. Once a person has been taking a drug for long enough, they can get to a point where either they think they can't survive without it, or they actually can't survive without it, or both. So psychological dependence is when a person just thinks they can't survive without the drug. And then physiological dependence is when a person's body actually needs the chemical in order to function normally. So once a person has psychological dependence and physiological dependence, that is a surefire sign that someone has an addiction to a substance. Now, addiction is considered a disease that you have to live with for the remainder of your life. So some people will choose to abuse substances with the assumption that, oh, someday I'll just stop and it won't be a big deal. Well, someday a person can stop and their body can tell them, no, don't stop, we're going to die without it. And that becomes a huge problem. For this reason, never try to diagnose yourself or a loved one with an addiction, okay? You should always seek advice from a professional before you try to claim that you or someone you know or love suffers from an addiction. Now, one of the big problems with developing an addiction means that those people are often going to develop a tolerance. So when somebody is abusing a drug frequently and aggressively, they can often end up just getting used to the drug and not experiencing the effects, even though they're using the same amount of a drug. So they're gradually increasing the amount of the drug they're taking each time. And this can lead to huge issues. Let's swing back around to that one. When somebody who has an addiction decides to stop taking the drug, they can experience what's called withdrawal. Now, withdrawal can be as simple as a headache that you get from not having a coffee after you've had a coffee 5 mornings in a row. And withdrawal can be as severe as death. So it's hard to know what to expect when a person decides to stop taking a drug. Another problem that comes about as a result of the combination of withdrawal and tolerance is that if a person develops a significant tolerance to a drug, goes through the process of weaning themselves from the drug, and then after some amount of time of having had no drug at all, they suddenly go back to taking the amount that they were taking before, that can cause an immediate overdose because their body has reduced it. The tolerance in their body has been reduced by the lack of the drug for any amount of time. All right, and that's pretty much it for drug classes and tolerance and addiction. Now, obviously, this is a topic that people spend their entire lives learning about and studying and trying to help out with. So this is a very, very truncated version. But if you have more questions, please come see me for office hours on Thursday. And Dr. Quigley and I will be trying to do another off-topic Friday. We're just going to have to find a solution for the problem we had last Friday. Anyways, I will hope to hear from you guys soon. Hope to see you guys Thursday. And that's all. Okay, bye.